Section 10.3, composite functions. Okay, so what we're going to do is we're going to take a value here, our x value here, we're going to times it by 2. That's the function of f of x. So just a different way of looking at things. So 2 times 2 is 4. And now I'm going to put this 4 into g of x. Okay, so 4 squared plus 2, 16 plus 2 is 18. Okay, we're going to do it again with 1. 2 times 1 is 2. Now 2 squared plus 2, so 4 plus 2 is 6. So your job for next class is to fill out the rest of this table. Okay, that's your job. And then I want you to decide which way could be used to obtain the results directly. So how could we go right from 2 to 18? Which of these ones work? Okay, and if you're not sure, what you're going to do is you're just going to sub in the value of 2 everywhere that you see x and see which one spits out 18. Okay, so that's your job. Okay, so before next class, now I'm going to do a little bit of the theory with you. Okay. Composite functions are functions that are formed from two functions, in which the output or result of one function is used as the input for the next function. Okay, so the output of one, this is the output of that first function, is used as the input of the next one. Okay. The composition of f of x and g of x is defined of f of g of x and is formed when the equation of g of x is substituted into the equation of f of x. It can either be written as f of g of x. So it's a function where I put g of x in, or the other way that I can write it is f of g of x. So don't confuse with multiplication. Okay, multiplication, we had that colored in dot. This one is an open dot. Okay, and order matters. F of g of x is not the same as g of f of x. Okay, I always remember these, I go inside out. Okay, I work on the inside and then I go outwards. Okay, let's try a problem. If f of x is 4 of x and g of x is x plus 6 and h of x is x squared, what is f of g of 3? Okay, so what I have to do first is I have to find what g of 3 is. Well, g of 3 means I take my function g of x and I put a 3 in for x. So I have 3 plus 6, which is 9. Okay, now I take f of 9, because g of 3 was simply equal to 9. Well, f of 9, I take my function of f of x, I go 4 times 9, and I just get 36. Okay. Here I have g of h of negative 2. So I start inside out. I do h of negative 2. So negative 2 squared. Sorry, I'm going to write this a little better and in a different color so we can see it. H of negative 2 means I take negative 2 and I square it. That is simply 4. Now I'm doing g of 4. So I go back to my g of x. I put 4 in where I see x. And I get 10. Okay. H of 2. Inside out. Well, h of 2, I take my function, h of x, I put 2 in where I see x. This is 4. Now I substitute 4 in here. So it's h of 4. So that is x squared. 4 squared is 16. Okay. Another way we could have done this one, this first one here, f of g of 3, is I could have done, well, wherever I see x in F, I put G. Well, that's x plus 6. So it's, sorry, F of G of x is equal to 4. Wherever I see x, I put x plus 6 because that is what G of x is. Okay. And now I could distribute that. So 4x plus 24. So F of G of x. And then it said I wanted to know, well, when the value is 3. So F of G of 3 is equal to 4 times 3 plus 24. Well, that's 12 plus 24. Okay, that is also 36. So another way to do that. Okay, and we could have done the other two in that way as well. Okay, here it says consider the function f of x is the square root of x minus 1 and g of x is x squared. I want you to determine f of g of x and g of f of x. Okay, so first I want to do the domain of each first. Okay, so the domain of this one, of f of x, well, x has to be greater than 1 or less than, no, it always has to be greater than 1. Greater than or equal to 1, right? Anything less than that will give us a square root of a negative number, which we don't like. And g of x, well, that can be any real number. Okay. Okay, so f of g of x, let's do first of all. Okay, so I take my function f of x. Wherever I see x, I put in x squared, because that's what g of x is. So I have the square root. Wherever I see x, I put in x squared, because that is g of x. Okay, so this is equal to the square root of x minus 1, x plus 1, if I wanted to keep it factored. Either of those would be correct. Okay. Now it's also asking us to do, we did this one, now it's g of f of x. So g of f of x. So I take g of x, which is x squared, but wherever I see x, I put f of x. And f of x was the square root of x minus 1. Well, whenever I square root, whenever I square a square root, I just get what's underneath the square root. So this is just x minus 1. So first of all, notice that f of x, f of g of x, and g of f of x are not equal. These two things are not the same. They are not equal. Okay? Now, what is the domain and range of each function? Okay. Well, let's look at f of g of x right here. Well, x needs to either be, if I have the square root of x minus 1, x plus 1, so x minus 1, x plus 1, and this kind of goes into a question that Raylene was asking before. Has to be greater than 0. Well, there's case 1. Either they're both positive. I can have a positive times a positive. So either x minus 1 is greater than or equal to 0, and x plus 1 is greater than or equal to 0. So either x must be greater than or equal to 1, or x must be greater than or equal to negative 1. Well, this covers all of that, right? If it's greater than 1, it's also greater than negative 1. Okay? That's the first way that this entire statement would be true. Another way this could be true is if each of these were negative. If I had a negative times a negative, that'd be greater than or equal to 0. So x minus 1, x plus 1, sorry, if this guy was negative, x minus 1 was negative, and if x plus 1 was negative, x is less than or equal to 1, x is less than or equal to negative 1. Well, this one right here covers both of them. If it's less than negative 1, it's also less than 1. So here's the two restrictions that I have on the domain. X must be greater than 1, greater than or equal to 1, or less than or equal to negative 1. So the way that I'm going to write that is I'm going to say f of g of x is equal to either x is less than or equal to negative 1 or x is greater than or equal to 1. Okay. Now in g of f of x, we always have to consider both the inner and the composite function. So g of f of x, x minus 1, it seems like there's no restrictions, but we still must honor that it was made up of the square root of x minus 1. So in that case, x had to be greater than or equal to 1. Okay, this is the domain. Okay, because what we originally had was the square root of x minus 1. Sure, it's simplified out to be just this, but we had to honor kind of like where it came from. Okay, so this is kind of something new, this concept right here. We actually did something similar to this in Pre-Cal 20 where we'd sometimes do a chart. You guys might not remember that, but just remember, like think about this logically. In order for both of these guys to be positive, they can either both be positive or both be negative. Okay. So make sure you have that table filled out for notes, and we'll discuss that and maybe do some more examples in class.